Hello, and welcome to another Into the Terminal. Today, we're going to be talking about links.
Not the
But-
text-based web browser, though.
Nobody remembers that. That's from like 1998. We're talking specifically about using the ln command in Linux to make links, and there are two kinds that you can make. What are the two kinds you make, Nate?
So there's symbolic links, and then there's hard links, and we're going to get into what each of those are as we go on. So don't ruin it.
I was not planning on it. You didn't know there was going to be a quiz, but we started with a quiz. Nate,
Totally
are you ready to jump in the terminal? And then we'll start with how one works with the ln command.
Yes, I am. And stay tuned. There's going to be whiteboarding. We know how much everybody likes whiteboarding. All right. So personally, when we started planning this this topic, I thought symlinks, hard links. I tried to think back how many times in my systems administration career have I ever used a hard link? And to be honest, I don't know if I could think of one, not even one. So maybe this will be informative for folks. So, all right, we're going to start out. We're going to set the stage here a little bit. I have a deep file here, right? So there's a directory in my home directory. Inside of there, there's like 4 levels of subdirectories, and there's a text file inside of that subdirectory. Now, completely simplistic use case. It's a pain in the butt to get to that subdirectory every time you want to get to it. So you could make a link between something that's easier to get to and that deep linked file. Now, there's lots of other use cases for that. Maybe you've got a service that runs that, it needs something in its working directory, but it can still follow the symlink out. There's lots of reasons that you might use a symlink that's less superficial than just I'm lazy and don't want to type a deep path here. So you can see, right, if I want to look at the file, I have to do super business 2025. Now this is easy with tab completion, but imagine that there were other subdirectories in here and I couldn't just tab my way through it, right? And then there's my file, my super businessy business in QE in quarter 3, right? What I can do is use a symbolic link, which is basically just a pointer. And maybe pointer is the wrong word, but it's really like a shortcut, I guess, is probably a better term here. And let me copy paste this because I'm already getting lazy with this path. We're going to do ln-s tells it to make it a symbolic link. And we're going to point to this super business 2025 Q3 reports, yada, 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 to a file inside of the working directory, which is my home directory, just called q3.txt, because I'm that lazy. I don't even want to type in report.txt. Now, if I cat q3.txt, we can see the contents of the super businessy business, right? So that's a symbolic link, right? A symbolic link is basically a pointer. If I do an ls-l on the q3 file here, you're going to see right here in the file system, it says this thing is called q3.txt, and it points to this other location in the file system, right? Now, it doesn't have to be within this directory. I could point to something that's in Etsy or something that's in the root or something that's in some other file system, wherever, right? I can link to almost anywhere. Okay.
And Nate, I think you said something very specific. You said you used the term shortcut. Right. I think that it is probably what people are most familiar with from something like Windows, right? Mm-hmm. Where you're adding a file somewhere, but that file really points to a file elsewhere on the system. And so you can have a locally convenient reference to it, regardless of, 87 directories away where it may live.
Right. Imagine this is buried somewhere in user local, some application, wherever, right? And you want to be able to get to this thing easily. You don't want to have to remember that path every time. That's exactly what this is for. It's a link to point you over there. Or again, make it convenient for a script you're running or an application you're running to be able to get to a file that's buried somewhere else in your file system. But there's another kind of link. We talked about it just a minute ago. That's a hard link. Now, a hard link, we'll talk a little bit more about what exactly that is in the deeper dive, but we're going to do a similar link here. I'll copy this out. We're going to paste it over here. So this time we're doing ln. By default, it'll make a hard link. If you don't do the -s, it'll make a hard link, right? we're going to link that same file to another file inside of the working directory, just called q3-hl, because it's a hard link, .txt. Okay. Now, if we look at the ls-l again, you can see there's our old Q3 symbolic link. It tells us right where that points to, but our hard link, it doesn't look like a link. It just looks like a file. And the reason for that is because a hard link actually links within the file system. It takes the file descriptor or the name of the file and links it to the same inode as the target, right? So they're basically both representations in the file system that point to the same inode, right? So this is a little more, a little less of a shortcut and more of a just second representation of the exact same file. And I don't know how else to compare that. I don't know that there's any other. I don't know if there's a way you even do that on other operating systems. Maybe on Mac OS you could do the same thing, but not like the shortcut comparison on Windows. So in the deeper dive, we're going to go a little bit more into how these are different and how you interact with them differently. Some of the limitations that come along with hard links that you don't get with symlinks, or sometimes called soft links. Some people call symlinks soft links. I don't know if you've heard that same terminology. I have over the years. But we'll show you exactly what those differences look like on the disk and how things behave differently.
All right, so stick with us as we get into more on the differences between symbolic links or soft links and hard links on the system. Nate, you'll be astounded by my whiteboarding ability today.
Yeah, we've got more whiteboarding. It's been a while since we've had whiteboarding.
And then we'll also talk a little bit more depth about how this lays out. We'll take questions from our viewers. If you're a deferred viewer, please feel free to leave a comment. Don't forget to mash that like and subscribe. And we'll see you after the swooshy swoosh for more Into the Terminal.
After the swooshy swoosh.
All right. So Shantanu actually already popped up in the chat and said the difference between hard and soft links is interesting from a interview perspective. So you should know what the difference is. So when you're interviewing for Linux jobs, you can tell people what the difference is.
I guess that's valid. It's good to have esoteric Unix and Linux knowledge when you're being interviewed, right?
Is it esoteric? I don't know that it is. Well,
like I said, the number of times I've used hard links, I can probably count on one fist, which means no hand, no fingers. I don't think I've ever used a hard link in real practice. So,
Nate, you make me sad. So I absolutely have used hard links versus symbolic links. I've actually had to make the decision on which one to use for a variety of reasons. So the first one is when you create a symbolic link, like Nate did there with Q3TXT, it is its own file.
Right.
So in the olden days, when the file systems we used had finite numbers of inodes, which are file pointers, if you created a huge mass of symbolic links, you used up all your inodes on a file system, and then you couldn't create any files to store data anymore. So that's an example of why one might use a hard link instead of a symbolic link, is because a hard link doesn't create any additional files on the file system.
And here's a representation of that, okay? So you see that the Q3HL, the hard link, has a inode, right? I did ls-li, which tells it to show us the inodes, and that first column is the inode, right? And you see over here, the q3.txt, which is a symbolic link, has a different inode. Now, if I did an -li on the actual file that we linked to, you should see this inode for the hard link and this inode for the actual file are the same thing. Where with the symbolic link, it's different. So the symbolic link gets a new inode, a new entry in the inode table. Even though it's a teeny tiny file, it still consumes an inode.
Well, and if you use something like df-i, you would see your usage of inodes.
Right.
And it's not as big of a deal for us on RHEL because we use XFS, which dynamically allocates inodes as we need them. But on ext3 or 4 file systems, where they're created at format time, and you can only get more by extending your file system to get more, that's a place where it was a problem. And even before that, we had ext2 and Berkeley fast fat file systems, like that kind of stuff, where inodes were a limited resource. And so, like, to give you a real life example of how this was important. So way back, I would compile software for different systems. And some systems could actually use the same compiled software, right? So, like, for example, somebody's like, I'm using RHEL 9.2. And somebody else is using RHEL 9.3. They can use the same compiled binary because they're both versions of RHEL 9.
Right.
But that's not
They're
always
close
the
enough,
case.
right? Yeah, all
Right.
the core
That's not
libraries and
always
whatnot are the same. Something compiled on one will probably work on the other. Right. Not always the case.
right. But like trying to compile a piece of software that's RHEL 8, it may not
Right.
be the same binary, right? All right. So I had like all these different software packages that I had to compile, and then I had to make them available for people for their release of Linux. And I also had to span Linuxes. I couldn't just compile things for RHEL. I had to compile things for other Linuxes too. And so
Right.
I put together this catalog, and people could like go to, /opt/ their Linux ID / their version number, and then they could find the executables they needed. So I would go through and create a ton of symbolic links so that that directory path was consistent and available for them. But on the back end, I only had one version of GIMP compiled for RHEL 9. Right. So if they went into 9.2, they went to the RHEL 9 version of GIMP. They went into 9.3, they used the same exact version of GIMP. But I had to support so many different Linuxes and versions that all of a sudden I was making thousands of symbolic links because I had packages times the complexity of Linux type times the
Right.
complexity of version times the complexity of minor version. And I ran out of file system inodes because I was creating all those links. And so that's a place where I went back and refactored everything to use hard links, because really there was only one copy of that binary on disk for all these different versions. And so I could use a hard
Right.
link, which didn't consume any additional inodes, and everything was fine. The other difference between them, and for like, you get your own inode. Hey, Nate, can you chmod the Q3 TXT symbolic link and make it 600?
No, I can't. I can show you that, but no. I don't think so anyway. I think it just, or does it change it at the target? Let's look here. Okay, so the symbolic link did not change. Been a while since I've done this. You're right. So it changed it at the destination, at the target.
So it followed the link and changed it to target. You
Right.
can actually, I think, use some foo to force those changes at the link level rather than having it follow the link, because it's a separate file with its own permissions and its own ownerships, right? So like, it could be that I own that file, report txt, and when you try to chmod it on your symbolic link, you get an error because you're not the owner and you are not permitted to make changes as not the owner.
You'll also notice that when we did that, the hard link that we made got updated because it links to the same inode, which has the same permissions. So I guess that's a thing to be aware of if you're using hard links.
And if you did something like chown or chgroup to change the owner or group owner of the file,
Right.
Depending on how you're calling it, it may change the owner or group owner of your symbolic link, because that's a file you own. It may not change the owner of the file to which it is linked. But if you change the hard link, it definitely changes in both places, right? The local reference to that file and the remote reference to that file, because they're actually the same exact file on disk.
Yep. Yeah, you can see it there. I changed the group on the Q3 hard link, and it changed the group on the deep link as well, or the deep file. I don't know what you would call it. The deep web.
So Nate, do you want to do some whiteboarding? We can actually like look at some of the
Sure.
how this happens in real life. Okay. Oh, let me put that here. There we go. So we've got our disk, and our disk has a file system on it, and the file system has the inode tables on it, right? So in here are like little blocks of file pointers, and they're numbered, right? So when Nate showed you the ls-i, and we saw the number next to the file, that's the actual number in this table where we store the properties of that file. And so we have our directory. So this is maybe Nate's home directory, and then Nate's super businessy business directory. Right, and I'm purposefully making the name short. Because I don't want to write the really long name in my terrible squiggly handwriting. All right.
Why not? It looks like that would be great and easy to, and it would make for really good content.
Right, exactly. So Nate, what was the inode number of your report for Q3 there, the report txt?
Let's see here. The inode for the report file. I mean, it's like an 8-character number. You really want to write the whole thing out? It's 185 10975.
Okay. So in the inode table entry for this directory, right? Directory is basically just a list of files by name and the associated inode that they're stored with on disk. So like over in here, somewhere in this little inode table entry, there is an inode entry for 185.109.75. And inside of this, this directory structure, there's a mapping that goes report txt is this inode number. When we look at that inode over here in the table, we have all the metadata about this file, right? So we get its permissions, which are right now something like that, right? 600 is what we change it to. And
Right.
we get the owner, and you change the group to something else.
I changed the group to RHEL because it was the only group I could think of off the top of my head.
Yeah. And so we have these properties of the file, right? And then at the very end, we have a space for data block pointers. So over here, this is where we store the actual disk addresses that store the contents of that file. So that points to like places out on the disk to the data blocks where the contents of the file are stored. And so what happens is when somebody goes into this directory and they look up report txt, the system looks at this inode number, which then takes it over to the inode table, which then has it pull up this inode table entry. So it can access the metadata for the file, and we can do things like check the permissions on it, check to see if they're the owner or group owner. So that would change what permissions they get. And then if they're allowed access to it, we can go and actually reassemble the file by looking at the data blocks to which the pointers point. All right. So when we created the Q3 txt symbolic link, that had its own inode number, right, Nate? What was it?
Yep. So the symbolic link ended up with a inode of 2038. I don't know if there's like a reserved section of inodes for things like links. It seems funny that that's such a small number when the other one was such a big number, but it is what
Yeah,
it is.
so inode tables, basically, like, we consume what's there, and then we wrap back around when we hit the
Okay.
maximum amount, and yeah, so, but it also depends on the file system. Different file systems will allocate inode numbers different
Yep.
ways. Could be using a hashing algorithm, like, there's a bunch of different options there. All right, so, also over here in our inode table, there's an inode entry for inode 2038, and it's got its own piece of data, right? So, like, 2038. It was a type L, so it has its own file type, right? So we're used to
Mm-hmm.
seeing things like dash or D, right? Dash means regular file, D means directory. So it's an
Yep.
L, and then RWX. It had an ownership,
Yep. Root.
and then instead of data blocks, instead what it has is the location of the file to which it points. So it points to this guy. And so here, the way that the file gets looked up is when we're working with Q3TXT, like you did cat on it. So cat comes out here to the directory. The directory says you need to look up inode 2038, right? So it comes out here. And then it goes over here and looks up inode 2038. And then here is inode 2038. But instead of going out and retrieving the data blocks that go with that file, it sees that what's stored in inode 2038 is a symbolic link. So now it goes out and looks up the linked file, which is inode 185.109.75. And then it goes out to the inode table again. And then it goes and looks up that inode entry. And then it checks things like ownerships, permissions, blah, blah, blah. And then it's able to access the data blocks to reconstitute the file for the cat.
Now, an important distinction though is the link. It can't be going directly to the inode. It must be using the file path. Because if I
That's correct.
change or delete that path, then it can't find it anymore, right? So if
Well,
I
and
had like
actually,
28 hard links that pointed to the same inode, and I delete one of those hard links, and the symlink was pointing to that hard link, then the symlink breaks.
yeah, and I actually would love to see a little bit later when we get back into the terminal an example of that, right? Where we remove the
Yep.
source file and we'll actually see the symbolic link break. All right.
It's almost
So,
like you've seen the episode guide because I have that exact example.
um, right. So essentially, we're doing two lookups for our symbolic link, right? We have to look up the symbolic link, then we have to look up the file to which it points, and then we can actually access its data. Now, imagine if your symbolic link pointed to a symbolic link, which pointed to a file. All right. So that's the other reason why one might choose hard linking instead of soft linking. Because if you build
Right.
this big chain of soft links, now you're like constantly having to bang on the disk to look up the next soft link, to look up the next soft link, to look up the next soft link, to finally get to the data for the file that you wanted. So, as you make those trees deeper, you're doing more disk lookups to
Right.
find that ultimate file again. Now, there's some stuff that we've done over the years to optimize on that, like file system caching to help out for things that we constantly use that get stored in memory, and like that eliminates that. But like the theory is if you're doing chains of soft links, things could be slower. So that might be another reason why you would choose a hard link. All right, but why don't we erase all this, or at least erase some of it, and or erase all of it apparently.
Yeah, you
Um,
could just erase all of it. That's fine.
let's do this. Not my best erasing, but it'll be okay. All right, so let's do that. That'll be nice. Okay, so how's this different when we instead use a hard link? So Nate, what was your hard link name?
Hard link name was q3-hl.txt. Super creative.
All right.
There's holes
So
in
we
your disk. I can't. This is so inaccurate.
We have this file q3-hl.txt that you can barely read from my terrible scribbling. But when we looked at it, it was also inode 185.109.75. And so instead of pointing out here with its own inode, it instead pointed to the exact same spot. And when we looked at it, it had the exact same information, right? It was actually, and I don't even need to draw it down the bottom because it's actually this guy, the exact same thing. But there is one difference. Nate, in the episode guide, do you talk about number of links field in your ls-l?
No, I did not touch on that.
All right, so here's what we're going to do. I'm going to add one thing to my inode. So in the original listing for the file, there's a field in your inode called the number of links. And when we only had one listing for that file, it was set to 1, right? But as soon as we created that hard link, and we'll look at this again when we get back into the terminal, it got updated to 2. And that tells me that on the disk, in the directory structure, there's actually 2 places where the same exact inode number is listed in the directory structure. And so if I added more and more hard links, that number of links value would just keep increasing to match the number of times this file was listed in the directory structure.
Makes sense.
When you
that way the file system knows when it can actually clean up the inode.
Well, yes, and also you as the owner of the file or someone using the file can know how many listings out there in the directory structure exist for this data that's stored on disk. And when you remove a hard link, it also will adjust the number of links field in the inode. So if we deleted this file here and removed it, then that would take the number of links field and reduce it back to 1, right? Because there's only one directory listing for this inode left in the directory structure. So that's my planned whiteboarding, Nate. What do you think?
It's been a long time since we've whiteboarded. I hope everybody appreciates the effort.
So any questions or any clarifications I provide? Before
there was some conversation going on. Somebody, I think it was Shantanu, was looking at the man page for Chamaad and Chone to see if there was mention of how to update a symlink, but I don't think we ever got an answer to that. So I don't know what your research has unveiled or uncovered there, Shantanu. Feel free to throw it into chat if you found something, some kind of revelation. But yeah, other than that, there was just some back and forth about links and whatnot. Some stuff about ext4 and how it allocates inodes. Rick was talking about. Yeah.
Cool. All right, so let's take a look at some of this in action, Nate. Let me
sure
pull
thing.
your terminal up. All right. So if you do a long listing and in your directory, you should see the ln-hl. See that second field, the number is 2. That's the
this one here. Okay, cool. Why Super
And
Business 3 then? That doesn't make any sense.
well, so directories always have 2 by default,
Okay.
but more if there's more links. So if you do an ls-la, so you see up there at the top, there's a dot.
Yeah.
What that is, it's a hard link to this directory. And
There's
so
4 other things that link here.
directories inside of themselves have a dot, which is a hard link to themselves. And so
That
they
makes
end up with
sense.
2 links for a directory by default.
So if
Great
it
mystery.
has would that mean
So
if there's a directory inside of the subdirectory, then ... for that directory would be a hard link back to the parent, right? And then that would make another link,
yeah. And so like,
which is why there's 3.
and for dot that you have there under the total 68 line, well, and there you go. You have
There we go. We've proved it. My new directory test, which has no subdirectories, only has 2 links. Cool. I learned something today, Scott. Thank you.
But when you add a test, look at the top dot link, right?
Now
It
it's
used to have
6.
5 links and now it has 6 because there's a directory test that has a dot link to this directory.
Lots of fun.
Yeah. And that's where things like find with the inode number is really handy.
I want to see what. I was only 18. I thought there'd be a lot more.
Why? If you look, there's probably 18 entries in there. And
Yeah.
symbolic links don't have a link to
Yeah,
their,
I was just thinking about like all the subdirectories that are beneath there. I thought there would have been a higher number, but okay. I guess it only goes 2 levels deep anyway.
the subdirectories underneath there have their own parent as their link.
Right.
Not their parent's parent as the link. Yeah. Cool. So let's pull up your thing real quick, your listing of your current directory. And I want you to remove the original file that you had down in Super Business, the report.txt.
Okay.
Okay. And now do an ls-l again, and we should see that the Q3HL.txt is now a 1 link. Oh, but Q3.txt.
Poor Q3.txt is broken now.
And thanks to our friend colorized ls output, it shows up as red. On some systems, it'll actually like blink to tell you that that symbolic link is broken, right? That the
blink should be illegal, especially in the terminal. So this is better this way.
So you know, now if we try to follow Q3.txt and we do that like redirection back to the disk again, we can't find that file name in the directory listing to then look up the inode to go to the data blocks. And that's why it's busted, because we can't follow this directory path anymore. But thankfully, if you look at Q3HL.txt and you look at its contents, what's in there?
Yeah, it should be identical.
So like,
now if I were to like,
oh, I don't think you want to copy it. I mean, I guess you could copy.
I could make a new link, I guess. Right.
Yeah, to put us back where we were, you would create another hard link. And that should reestablish the symbolic link again.
Yeah, it works again because it literally points to that path in the file system. Has nothing to do with inodes or contents or whatever. It's literally the name. If I were to simply rename that, even though it's got the inode, it would not work.
So Nate, why did I stop you from making a copy?
Because it wouldn't have been a link. Like it wouldn't have pointed to the same inode anymore. It would have been a second copy of the data.
Right. And so you would have had 2 files with the super businessy business in Q3.
Right.
One, which was Q3HL.txt. And now you would have this thing down in your directory structure, which would be a separate and different file. And now if you change Q3HL.txt, it would not change the other one because they're now 2 separate files stored on the file system.
Right. Right. So any changes, I guess it's kind of pointless to demonstrate this at this point because we've really kind of worked it. But any changes that happen to Q3HL, Q3TXT, or Super Business 2025, Q3 reports, assets report.txt, all will show in all the places because they all point effectively to the same place. So yeah, I was going to demonstrate that, but I don't know. Is it really worth it?
Oh, yeah, there you go. It's like, don't overwrite the file.
So we're going to put it in the symlink, which should put it into the destination, which was the original file, right? Which is now a new hard link, right? And if we look in the Q3-HL, we should see that change, right? There's more data, right?
Yeah.
And we should also see it inside of that report file. Right there, more data. So there's, in some ways, hard links can, I want to be very careful how I word this. Hard links can not be used as a backup because they are not a backup. Changes that happen in one place will happen in all the places, but they are a little bit of protection against deletion, right? Because if you have 4 places that hard link to the same file and you delete one of those files, the other 3 still work, right? So you could recover the data, which is exactly what we just did.
Yeah, and when we're talking about the number of links, and you said, oh, that'll keep it from, when it's decremented, we'll know when to remove it and reuse the
Right.
inode. That's exactly it, right? As we delete all references in the directory structure, it's not until you reach 0 entries in the directory structure
Right.
that file's actual data on disk will be marked for reuse, and the inode itself gets marked for reuse. Which leads us back to like, well, how do I know where all the things are? So you can use something like find -inum on your inode number, and it will tell you all the places where that thing exists, right?
Inum, you said, right?
Yes, inum, and you're looking for 185.109.75.
7.3, right? 7.5.
75. That's it.
There we go.
And so it shows you all the places where that file exists. And if you, instead of looking dot, you actually said slash, it would look over the entire system for inodes,
Right.
have that inode number. So that's how you can, like, if you see a 5 on your number of links,
But where does it link? Right.
Exactly. Like, wait, somebody put this in their home directory. Well, how do I get rid of it if I'm really trying to delete my data? Like that becomes a concern.
Right. Right.
So there is one other situation with linking, with hard linking, that I wanted to cover. And I did not pay close enough attention to the episode guide to know whether you had already put it in there or not.
There are actually 2 edge cases, two limitations that we highlight in the episode guide, and I think that's exactly where you're going next.
Yes.
One of them is
So
across file systems. Yes. One of them is you can't hard link across file systems, and the other is you can't hard link a directory. So if I try to do a link on Super Business to business, right, which is another directory that doesn't exist, it actually can't, right? It tells me hard link is not allowed for a directory. And the reason for that is, what if I were to do something very silly, like put a hard link to a directory inside of that directory? Now you've got this infinite loop inside of your directory, and the file system is trying to protect us from that. Link is trying to protect us from that. So you can't hard link directories. If you need to link a directory somewhere, you could do either a symlink, or you can use a mount bind. You can use mount to bind a directory to another directory. However, I think you could end up in the same loop situation if you're not careful. So just keep that in mind. But you cannot use link to link a directory. You can link files, not directories. Then the other thing is across file systems. And you could imagine, right? The inode table is per file system. So if I hard link outside of the file system that the file is in, so if I did a link, I happened to make a nice mount over here, it'll tell me, no, you can't do that either. Can't create a hard link, log.log to mount bootstrap.log invalid cross-device link. And that's how you know, oh, I've left the file system that I'm on, or I've left the device that I'm on. Because the inode tables are different, right? The file system can't, well, maybe it could, I guess, if somebody extended the file system to do this. And maybe there's a file system that exists that'll let you do it. But the inode tables are different. So there's no way to say like this device, this inode. It's just inode. So we can't link across devices or across file systems.
Yeah, because when we looked at when I was whiteboarding,
awesome whiteboard.
The directory listing had the directory entry, right, the name of the file, and an inode number. There wasn't anything in there about the file system or the device on which it was stored, right? So it looks within the inode table of the current file system for that inode number. And so if you try to create a hard link across file systems, that other file system that you're using, it may also have an inode number that is the same as the one you're trying to reuse, right? Or it might not, because maybe the file system is smaller and it didn't make that many inodes.
It just point to nothing.
Yeah. But you can solve this with links. You just can't use a hard link. What would you have to use instead?
You'd use a symbolic link instead. Or again, I think those mount binds would do the trick. I don't know if you could do that for a file, maybe for a directory.
Yeah, I would use a symbolic link if it was me, right?
Yeah, I think a symbolic link is the right way.
Yeah, references the directory, right? The file in the directory. So mount bootstrap.log, we know how to navigate the file system to find that file and retrieve it, right? And so we can use that like extra redirection that symbolic links provide us to go into the directory structure, find that listing for the file and the inode number to then go out and get the inode and data and other stuff that goes with it. Man.
So that's it for my demos. We have a little bit of recap between hard links and symlinks. So remember, hard links, they point to the same inode. So you could argue that they kind of act like a little bit of protection against deletion, but not a backup. Do not think that a hard link is a backup. Do not take away from this. Nate told me it was a backup. No, it's not a backup.
That's right. If you want a backup, you want a copy.
Right. You want a copy, and you want that copy stored in places that is safer than just right here on the system that you're working on. Hard links can be used to sometimes make files available, like say you have a service that runs inside of a chi-rooted environment and it needs a file that's outside of the chi-root. You could use a mount bind to get that file into the chi-rooted environment, right? So that way you don't have to have a second copy. Symlinks will break in that case because in the chi-root, unless that symlink is inside of the same chi-rooted environment, it's not going to be able to find it because it goes outside of the chi-root, right? So that's a thing to keep in mind. It could maybe help you out if you're like mapping data into containers or if you're, whatever. There's lots of use cases that might work. But you can't link directories and you can't cross file systems. So those are good reasons why you would not use a hard link, because you're leaving the file system or you need to link to a directory. Symlinks, of course, can do those things. But if the original file is deleted, then the symlink stops working. And I would argue that symlinks are probably usually your default, right? Like those are the things most people are going to use commonly. I don't know why the link tool defaults to hard link instead of symlink, but I guess that's probably historical. Maybe when link was written 30 some years ago or whatever, that was the common way to make this happen. So there you go. So hard links versus symlinks.
It is historical why symbolic links are not the default. Remember I told you that like you could exhaust your inodes. So you had to specifically request an extra inode using the -s option to make a symbolic link. Also, I told you about how the redirection would actually potentially slow down your disk lookups. And then now we used file system cache and other stuff to help ease that. Well, way back in the day, we didn't have those technologies. And so doing a double lookup could significantly slow down your disk IO. And so that's why hard linking is the default and symbolic link requires the -s option. I think both of those are relatively not concerns anymore. But link is a tool that's been around for eons in Linux and Unix.
Exactly. Right. So I figured that it was a historical thing. And yeah. So back in the old days, hard links were more popular. Now they're not. Back when all the computers were fueled by coal.
That's right. I used to shovel it in as I was sitting there. I'd like do a shovelful and then clack-a-lack on the keyboard, and then do a shovelful.
I thought that's how that worked.
Yeah. The steam powered computing.
Steam powered computing. Yeah. All right. I think I think that runs us off the end of the prepared demonstrations.
Yeah, the 1850s want their computers back, Nate. Thank you. All right. So don't forget, we can drop a comment. Nate and I will respond to it. Next week, we actually are not doing it into the terminal next week because it's Q3 recharge for Red Hat, Nate. So Nate and
I saw someone cancel all my meetings on Friday, and I thought, what's that all about? And then I looked at the calendar.
Yeah. So Red Hat has a company holiday next Friday, so we will not be with you there because we'll be off doing non-worky things. But in 2 weeks, we will have another Into the Terminal episode for you. I don't know that we picked out what it was yet.
I don't think we have one planned. We'll get one out. Shantanu suggested we do an episode about rsync. It's not a bad idea. I threw that onto our list of possibilities.
Okay. So there you go. More than you ever wanted to know about hard links and probably not like wasted your brain space.
No, I think this is good data. This is good information, right?
Well, now you can answer all those interview questions that Shantanu apparently couldn't answer. I'm teasing.
Yeah, right. You are now all better than Shantanu was when he interviewed for whatever that job that was.
All right, everybody. Well, thanks for joining us, and we will see you next time in 2 weeks for another episode of Into the Terminal.
Everybody have a great one.